Welcome to Spring LIB.
We're actually asked to exercise a previous exercise, exercise 37, if one piece is bent into a square and the other into a circle. So there's really two parts here. So we're given a certain amount cut for the square. We'll call this amount x. And the amount cut for the circle, this will be 10 minus x. Now the side length of the square is x over 4. And the circumference of the area of the square is a function of x. This is x over 4 squared, which is x squared over 16. On the other hand, the circumference of the circle, this is the same as 10 minus x. So we have that 2 pi r equals 10 minus x. And so r as a function of x is r equals 10 minus x over 2 pi. And the area of our circle was a function of r, this is pi r squared, but then substituting this is pi times 10 minus x over 2 pi squared. This simplifies to 10 minus x squared over 4 pi. Now the total area of our figure, which I'll call A, this is the area of the circle plus the area of the square. So this is x squared over 16. So again, the total area is the area of the square plus the area of the circle. So x squared over 16 plus 10 minus x squared over 4 pi. Now we want to differentiate. So a prime of x is x over 8 plus 2 over 4 pi is 1 over 2 pi times 10 minus x times negative 1. We want to solve the equation a prime of x equals 0 and the critical points. So we have, let's see, x over 8 equals 10 minus x over 2 pi. And then cross multiplying and solving for x, we get x is equal to 80 over 2 pi plus 8, which is approximately 5.6. Now we'll evaluate our area at this critical number and at the endpoints of the domain, and we'll compare. Well, our domain is from 0 to 10. This is the values x can take. So a of 0, well, this is 0 plus 10 squared over 4 pi, which is 100 over 4 pi, or 25 over pi, which is approximately 7.96. On the other hand, a of our critical value, which is 80 over or I guess I'd say 40 over pi plus 4. Plug this in. This is approximately 3.5. And if you plug in 10, a of 10, this is 100 over 16, which is about 6.25. So from all this, it's clear that the maximum area is obtained when x equals 0. So A is maximized when x equals 0. So the answer is all wires should be used to make the circle. And to find the minimum, well, we also see that the area is minimized when x is equal to 40 over pi plus 4, which, as we already saw, is about 5.6, and therefore, in this case, about 5.6 meters of wire should be used for the square, and the remainder, 10 minus 5.6, which is 4.4 meters, should be used for the circle.